We can also create a spline by using the Spline tool. A spline is a smooth curve that is composed of series of points. These points are known as spline points. To create a spline, we use this icon as shown here. We need at least 3 mouse clicks, which form 3 or more points out of which the spline is created. If you want to edit or modify an already created sketch, how to do that? Well, there are various sketch operations to modify a sketch. The first option that we will see is the Sketch Fillet option. The Sketch Fillet option cuts off or rounds off the corner which is formed between two sketch lines. The next edit tool is the Chamfer tool. Using this tool, we can make a straight cut in a corner made of two sketch lines. Now, we are going to see an important concept in sketching. It is known as constraints. What are the reasons to have constraints? Well, constraints, as the meaning of the word is, are there to fix a sketch in position and location, as well as dimensions. They impose geometric limitations on sketch entities. They also lock up the position on the sketch plane. There are two ways in which sketch constraints work. In the first approach of constraints, we fix the relation of a sketch to its plane. Hence, it cannot change its location or position or size with respect to the plane. In the second method, we fix the relation of the sketch to another sketch. Constraint offers an indirect advantage. In the process in which we create a sketch, we do not have to think about fixing or taking decisions on the size and position of a sketch. When creating sketch, we can just go on creating them and then put constraints to one by one, bring them to final form. We are going to see all the different constraints one by one. The first constraints tool is the coincidence constraint. This constraint forces a point on a sketch entity to coincide with another sketch entity on a plane. We can use a line or circle or arc or another point as a reference entity. The next constraint tool is the Collinear tool. Using this constraint, we can force two sketch entities to lie on the same line. As shown here, we have fixed the two edges of these two rectangles to be collinear with each other. The concentric constraints are the next tool. This constraint forces two sketch entities to be concentric with each other, that is, having same center point. We can apply this constraint on two or more circles or arcs or ellipses. As shown in the figure, the circle and the arc are forced to be concentric. The next constraint tool is of equal length. This makes the length of two sketches to be the same. This constraint works only with lines. As shown in the figure, we have made the two sides of the triangle to be same by using the equal length tool. The equal radius is another constraint tool which sets the radius of two circles to be the same. As shown in this figure, the two circles have same radius. The constraint which we will see now is the fixation constraint. This constraint tool anchors the position of a single sketch entity on the sketch plane. This can be applied to almost all sketch types. We will now see the horizontal constraint. This tool aligns a sketch with x-axis. As shown in this figure, the top edge is now aligned or parallel to x-axis. The vertical constraint tool works in a similar fashion to the horizontal tool. This tool also aligns the sketch, but with y-axis. As shown in the figure, the right edge of the rectangle is parallel to or aligned with the vertical axis. The next tool that we will discuss is the Midpoint constraint tool. This constraint forces a point to lie exactly at the midpoint of a line. This is used for a line and point combination. As shown in figure, we have fixed the point to be positioned at the midpoint of the right edge of the rectangle sketch. The parallel constraint tool is used to fix two edges to be parallel to one another. As shown in this figure, we have the two lines parallel to one another using this tool. Similar to the parallel constraint, we have the perpendicular constraint, which fixes two lines to be perpendicular to one another. The application of this tool is shown in this figure. The next constraint tool is tangent constraint. This constraint forces a sketch entity to be tangent to a circle or arc or ellipse. The entities that can be included in this constraint are circle, arc, ellipse, and line entities. As shown in this figure, we have made a circle and triangle edge to be tangent to each other. The next tool for constraints that we are going to discuss is the pierce tool. This type of constraint tool forces the point to pierce the edge as shown in the figure. An important topic after constraints is sketch dimensioning. Now you may ask, what is the need to put dimensions to sketches? Dimensions act in somewhat similar way to constraints. They control or fix the final form of sizes, distances, angles in a sketch. In a way, they put values to every entity. The first dimension option that we are going to discuss is an angle. This dimension tool specifies the angle between two lines. The limitation is the angle must be greater than 0 and less than 360 degrees or 180 degrees. To fix or specify the straight line distance between two sketch entities, we use the distance dimension tool. The example is shown in this figure. Another variation of this distance dimension is the horizontal distance dimension option. This tool sets the distance in the x direction between 2 points. As shown in this figure, this is how the horizontal dimension looks like. The next variant of the distance dimension is the vertical distance dimension option. We use this option to set distance in the y direction between 2 points. The length dimension as shown in the figure specifies the length of a line sketch entity. The radius dimension as shown in the figure is used to set or specify the radius of a circle or circular arc. Minor radius is another variant of the radius dimension tool. It will specify the small diameter of an ellipse entity. The same is shown in the figure. The major radius option sets the major radius of an ellipse. Again, it is used in case of an ellipse. The example is shown in the figure.